So today the lesson we're going to cover is a brand new topic on rational equations. And so when you hear the word rational, you want to be thinking of fractions, okay? And when we think of fractions, we need to think of the numerator and the denominator both being integers. So for example, 2 over 7 would be a fraction, a rational number, because 2 is an integer, 7 is an integer. I could go negative 4 over 9. That would be a rational expression because I have a negative on the top and a 9 on the bottom. However, we've worked with things that might have radicals on them. I don't know, 2 root 3 over root 5. This can sort of be considered as a rational expression, but it can't be considered a rational number because it doesn't have an integer on the top or bottom. So these would be rational numbers because they're integers on top and bottom. I would just consider this a rational expression. It's expressed in a fraction, but it's not a rational number. So when you're thinking of a rational expression, you can kind of think of the same idea as a rational number, but your numerator and denominator must be polynomials. So the numerator and denominator, the top and the bottom of the fraction, must be polynomials. So when I deal with rational expressions in this unit, I'm going to have a polynomial on the top and a polynomial on the bottom. So when we're dealing with polynomials, it's important to consider what is a polynomial. So to be a polynomial, to be considered a polynomial, the variable in the expression, like any variables that are involved, cannot be negative. So we couldn't have y equals x squared plus 2x plus x to the minus 1 or something of that sort. I can't have any negatives in the exponent because it's not considered polynomial. I cannot have any exponent variables. So what I mean by that is I could have x squared plus 2 to the x, but this x in the exponent makes this expression not a polynomial. You can't have radicals on the variables. So for example, I could have x squared plus x to the 2 over 3, or maybe something like y equals x squared plus square root of x squared, or something like that. That is not allowed because that's not considered a polynomial. Okay, so basically we can have a number times a variable squared plus a number times a variable plus a number, kind of like your quadratics. It could be linear, or it could be something that has a higher exponent than 2, like a 3, a 4, or a 5. But most of the time, the expressions we give you need to be able to be factored. And kind of in this course, we've learned how to factor quadratics. But you'll get mostly quadratics, but you can have numerical numerical whole number exponents, and that's it. Okay, so we have a polynomial divided by a polynomial. Now, basically, anytime you deal with rationals, you can't have the bottom of the rational or the fraction be 0. So I'll just say denominator cannot equal 0 because that's problematic. Now this step will help us to find something we call to be a non-permissible value, or an NPV. It's called non-permissible value. So these are the things that make the denominator 0, okay? So any value that makes the denominator of the rational expression equals to 0 is called a non-permissible value, or an NPV, okay? And just in case you missed the abbreviation, we're just talking about a rational expression, which is a fraction divided by a fraction, or like a polynomial divided by a polynomial, okay? So we have non-permissible values, which everywhere in the notes, I'm going to write them as NPVs, or restrictions, okay? They're both considered the same thing. Anything that makes the denominator 0 is your restriction. Now, the first skill we need to be able to have is to find the NPVs, because this is telling you what the fraction is not allowed to equal. So what you're going to do is you're going to set denominator equal to 0. So that's your first step. Take your denominator, set it equal to 0. The next step is to solve. Now, you may have to solve a quadratic like we've done in this unit, which would be a very good thing to do because that's the whole reason we learned how to solve quadratics, is because there's other purposes for them. Okay, so first example, find the NPV or restriction. So what I want to do is I want to take my denominator, set it equal to 0, and solve for my variable. So my variable here is m. I'm going to divide this side by 2, divide this side by 2. So m is equal to 0 divided by 2, which is 0. So I'm going to come back and say m is not allowed to equal 0. When it does equal 0, I have a non-permissible value. Okay, so we can say 2m is not allowed to equal 0, m is not allowed to equal 0. Or you can just set it equal to 0, solve it, and then put the not equal to at the very end. Okay? To find the non-permissible value, I take my denominator, a minus 3, I set it equal to 0, and I solve. This is a linear equation. I move the 3 over by adding 3 on both sides. So my non-permissible value works out to 3. So I'm going to go ahead and say a is not allowed to equal 3, because if I do equal 3, then I have a problem. I have a 0 on the bottom. So again, you can come back and put not equal to if it helps. Okay? In the next example, this is kind of the most difficult you may get, where you have to factor the expression. I take my denominator, set it equal to 0, and now I have to factor to solve. So this is solve a quadratic equation. So you can solve a quadratic equation. We learned 4 ways. We learned graphing, which is not an algebraic approach. We learned factoring. Okay. We learned completing the square. And we learned quadratic formula. So let's say for this example, we're going to use factoring just to review our factoring skills, because I know it's been a while. We need 2 numbers to multiply to our a times c value and 2 numbers to add to our b value. So here's my a, here's my b, here's my c. So my a times my c, so a is 1, b is negative 3, and c is negative 4. So 1 times negative 4 is negative 4, and it has to add to negative 3. So you need to determine what 2 numbers do that. I know negative 4 times positive 1 is negative 4. I also know that negative 4 plus 1 is negative 3. Now, most of you who know how to do decomposition never have problems with factoring. So I'm going to go back to an older technique, which is the box, and I'm going to factor this way. So I'm going to write my x squared and my minus 4 at the bottom. And then the 2 numbers I found go in the middle 2 terms, but I put the x back on them. Now our goal is to say what's in common. There's an x in common. What's in common out of this column? It's a negative 4. The first box is negative, so I take out the negative. What's common along this row is an x, and what's common along this row is a 1. So in this case, when I factor this expression, I get an x plus 1 and an x minus 4 equals 0. So x plus 1 has to equal 0, which will give me x is equal to -1, because I'm going to subtract 1 on both sides. And x minus 4 has to equal 0, so x equals +4. So these are my non-permissible values. X is not allowed to equal -1, because that would make a 0 on the bottom. And x is not allowed to equal 4. So if you want to come back and put all of these as not equals, as you're thinking through it, that's fine. Or you can leave it as equal to 0, and then our restrictions at the end would be x is not allowed to equal those values. Now, just like we deal with fractions, it's important to simplify your rational expressions into simplest form. So simplest form means there's nothing uncommon on the top or the bottom. Okay, so let's look at a fraction for a sec. If I have a 4/8 and I wanted to simplify that, both of these numbers are divisible by 4. I want to look for the greatest common factor. 4 divided by 4 is a 1. 8 divided by 4 is a 2. So 1/2 would be my identical fraction. If I want to do this with variables, what I want to do is my first step would be to factor the numerator and denominator using your skills from RF1, which is your factoring skill. And then what we need to do is divide out common factors. So I'm going to say divide out common, but I'm going to use, instead of comment, I'm going to use the word identical. So I only want you to cancel out the factors if they're identical factors. Okay? Now monomials, one term can only cancel out other monomials, and binomials can only cancel out identical binomials. Super, super important, and anytime we deal with canceling, this is one of the biggest areas people make mistakes. So for example, let's say I factor the top like this, and I factor the bottom like this, okay? These are considered binomial terms. They all have two pieces, x plus 2, x minus 2, x minus 1. When we're canceling them out, we need to cancel them out being identical. I see an x plus 2 identical to x plus 2, so I can cancel them out, and I'm left with x minus 1 and x minus 2, but I also need to consider my NPVs all the time, every question. If I have a monomial, so let's say this was my monomial. A monomial can cancel out with a monomial. So 2 divided by 4. 2 can simplify, divide top and bottom by 2. So I get a 1/2. The m squared, let me use a different color. The m squared and the m are common. They both at least have one m in them. So I'm going to cancel 1 out of both. So there's going to be 1 left on the top. And then if I look at my n's, they're both identical. So I'm going to cancel them out. So that would be my answer, just kind of in a generic way, but I want to make sure you kind of understand it, and you would still need to consider the NPVs. That would be the first step in any question. So let's just say factor, and then make sure NPVs are kind of done in between before you do the cancellation. So let's simplify the following and state NPVs. Okay, we want to factor, state the NPVs, and then we want to do cancellation. Those are my 3 steps to simplify. Okay, so first step is to factor. In this case, it's a monomial. You don't need to factor monomials, so we might want to say factor terms that are not monomials. Now I want to cancel, before I do that, I want to state my NPV. So I'm going to take my variable part of the expression, and I want to make it not equal to 0 or equal to 0 to solve it. So I want to set each variable equal to 0. So m squared cannot equal 0, and t to the 4th cannot equal 0. How do I get rid of the squared? I'm going to square root both sides. So m is not allowed to equal plus or minus square root of 0. So m is not allowed to equal 0 because there's no difference between plus 0 and minus 0. I want to get rid of this 4. So instead of square rooting, I'm going to take the 4th root of both sides. So t cannot equal the 4th root of 0. If you want to look for that button in your calculator, it's math, and then I believe it's number 4. Oh, no, it's like number 5, and then you can just help yourself use your calculator if you need to. T is not allowed to equal 0. So I'm going to state that m is not allowed to equal 0, t is not allowed to equal 0. So now I'm ready for my next step. I'm going to look at my m's. I have m on top, 1, 2, 3 m's being multiplied out, and I have 2 m's on the bottom. So 2 of them can cancel out with 2 of them. So I'm left with an m on the numerator. I'm going to look at my t squared and my t to the 4th. So that's kind of like t. I want to know how many of them can cancel out. Well, the 2 on the top can cancel with 2 on the bottom, and then I'm going to be left with a surplus of 2 t's on the bottom being multiplied out. And then I'd state my NPVs. M is not allowed to equal 0. T is not allowed to equal 0. That would be my final answer for the problem. Okay? In the next example, simplify and state the NPVs. So my first step is to factor. R minus 9. There's an R and there's a 9. This is a 1 and a 9. Nothing is in common other than a 1. Now on the bottom, I see a GCF. They're both divisible by 3. So my GCF is 3. So I'm going to factor out the 3. And I ask myself, what's left over? So 3R divided by 3 is R, minus 27 divided by 3 is minus 9. Okay, and I'm also going to get rid of this 1 just because I don't really need it. Okay, I'm ready to state my NPVs, so I'm going to take my denominator in its original form, and I want to set that equal to 0. So 3 R minus 9 equals 0, and my goal is to solve for R. Divide by 3, divide by 3. R minus 9 equals 0 divided by 3 is 0. I want to get the R by itself, so I'm going to add 9 to both sides. So R is equal to 9. So what I'm going to do is I'm going to come back and put not equal to, not equal to, not equal to. R is not equal to 9, because if it equals 9, then I have a problem. I'm going to get a 0 on the bottom. Now what I want to do is I want to look for identical factors on the bottom. If I put a bracket around here, which I can do because there's nothing else on the top, this is identical to this, so they cancel out. And what I'm left with is an imaginary 1 on the top, because there's nothing left. R minus 9 divided by R minus 9 is 1. And then there's a 3 on the bottom, but I still need to write my non-permissible value of 9. R is not allowed to equal 9. And that would be my simplified expression and stating our NPVs at the same time. Now, as the questions get a bit more complicated, the big thing is, can you make sure you're able to factor? And this is the only thing you need to kind of remember to factor. So I need 2 numbers to multiply to -6 and the same 2 numbers to add to -5 for the top part of my fraction. Now in this example, I'm going to do the swing method because I find it's actually a bit easier to deal with quickly. 2 numbers to multiply to -6, I can have -6 and +1. And then when I add those 2 numbers, I also get -5. I'm going to put those numbers in the bracket with my x. This is the swing method. -6 plus 1. But I also want to make sure that if there's an a value, I divide by the a. My a is an imaginary 1, so I'm going to divide both of these by 1. And I get x minus 6 divided by 1 is 6. 1 divided by 1 is 1. And so there's my factored form for the top. So I'm going to go ahead and write that in. X minus 6, x plus 1. Now I want to factor the denominator, which is x squared minus 36. This is a difference of squares, if you remember when we did RF1 factoring. The square root of x squared is absolute value of x, but right now we just want to write it as x. The square root of 36 is 6, and there's a negative in the between them. So the difference of squares was you write the x and you write the 6, the x and the 6, and one becomes positive, one becomes negative. Because when you distribute it back out, you're going to get the middle two terms canceling, which is exactly what we want to happen, and the other terms will kind of remain there. To state my NPVs, I'm going to take my bottom in factored form and set it equal to 0 and solve. So x plus 6 equals 0. Which tells me x is equal to minus 6. So if I sub a minus 6 in there, I'm going to get a 0 times something, which is 0. X minus 6 is equal to 0. So x equals 6. So I'm going to add 6 on both sides. So I'm going to come back up here and say x is not allowed to equal plus or minus 6. Okay. We're allowed to cancel out identical factors. I see an x minus 6 and an x minus 6. Those can cancel out. Nothing else is identical. Okay, so I'm going to use an arrow. X plus 1 is what's left on the numerator. And x plus 6 is what's left on the denominator. And x is not allowed to equal plus or minus 6. Okay. Now, next layer of difficulty, polynomial divide by a polynomial. More specifically, we have a quadratic divide by a quadratic. You're going to notice in both cases there's a GCF. On the numerator, all of those terms are divisible by 3. On the bottom, I'm going to check 120 is divisible by 6, so there's a GCF on the top and the bottom. Now, if you were to go and factor that and forget the GCF, your methods are going to have a glitch to them. Unless you're the kid that's doing decomp, there is not going to be a glitch, but you're going to still not be completely factored. So first step I'm going to do is factor out the GCF. So 3x squared divided by 3 is x squared. 33x divided by 3 is 11x. 90 divided by 3 is 30. So there's my numerator with my GCF factored out. Now my denominator. I'm taking 6x squared divided by 6, and I get an x squared. 6x divided by 6 is plus x. Minus 120 divided by 6 is minus 20. So you do the GCF first. Now I need to factor the top and factor the bottom. So I need x squared plus 11x plus 30. Two numbers to multiply to 30 times 1, which is 30. The same two numbers to add to 11. My numbers are 5 and 6, 5 and 6. Again, I'm going to do the swing method because I find it faster. Or you can use the box method. I'm going to put my plus 5, my plus 6. You have to identify your a value. So in this case, my number in front of the x squared is a 1. So I'm going to divide by 1, divide by 1. I get 5 divided by 1 is 5. 6 divided by 1 is 6, and so there's my factored numerator. X plus 5, x plus 6. So if you remember at the beginning of the course, I said that all of the quadratic stuff is going to show up in every single unit. The way the quadratic stuff is showing up in this unit is through factoring. So you have to always remember your factoring techniques from RF1. Okay, now I also need two numbers, my other polynomial or my quadratic, two numbers to multiply to negative 20 times the 1, and the same two numbers to add to positive 1, which is my B term. You identify your two numbers. Let's use purple again. Positive 5, negative 4, positive 5, negative 4. You come back and you start your bracket. X, X. I'm going to do my plus 5, my minus 4. And I want to divide both of these by my A value, which is positive 1. So I get 5 divided by 1, which is 5. And minus 4 divided by 1, which is minus 4. And there's my factored expression for the bottom. I carry through the 6 there. Kind of ignore it for the time being. So there's my factoring. Now my step 2 is to state the NPVs. So I'm going to just state it underneath. My NPVs, my non-permissible values, are coming from the denominator. Now I'm solving this quadratic equation through factoring. Or if you want to, you can take the original expression and solve where does that equal 0 or where is it not allowed to equal 0. Same step. You can solve it through factoring, which is this step. Once it's already factored for you, the factors are really easy to do. So you probably wouldn't be doing this method. You'd probably most likely be doing this one, but this one is optional for you. And you could use quadratic formula here if you wanted to. But it doesn't help you with the factoring too carefully. So I'm going to take my x plus 5 and make it not equal to 0. Minus 5 minus 5. X is not allowed to equal negative 5. X minus 4 cannot equal 0, so x cannot equal positive 4. So there are my NPVs. So I'm going to come back and simplify my expression. Do I have anything identical? I have an x plus 5 and an x plus 5. Now, this part of my expression is two fractions. They're kind of in the front factored out. I'm going to divide this one by 3 and this one by 3. I'm not changing the question. 3 divided by 3 is 1. So I'm going to get us x plus 6 on the top and a 1 out front if you feel like writing it. 6 divided by 3 is 2, and then I have my x minus 4 that's left over, and then at every step I have to write x is not allowed to equal the minus 5 and the positive 4. So again, x is not allowed to equal minus 5, positive 4, x is not allowed to equal minus 5 and positive 4. So you just want to make sure at every step the NPVs are kind of stated out, and that would be my final answer. So the trickiest part of this entire unit, or this entire lesson for today, is do you know how to factor? Okay. Now this one, my A value is a 2, so this factoring is a little bit different. Well, it's not that different. You can use your decomp. So I'm going to go ahead and factor the numerator. So I need two numbers to multiply by my A times my C, which is negative 20. And I need the same two numbers to add to my middle term, which is 1. And for the bottom fraction, I need two numbers to multiply to negative 10 and add to positive 3. So I think of my two numbers that do that. Be very careful. Positive 5 and negative 4 multiply to negative 20. 5 minus 4 is 1. In this case, 5 times minus 2 is minus 10, but 5 plus minus 2 is 3. So now I'm ready to do my swing method. Again, the swing method might feel the easiest in this case. So you're going to come in, you're going to write your brackets, x, 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 x. I'm going to put my positive 5 and my negative 4, my positive 5 and my negative 4. And then I want to make sure I'm dividing by the appropriate a value in each expression. This one is a 1, this one is a 2. So I'm going to divide this by 2, this by 2, this one by 1, this one by 1. So 5 divided by 2 can't be simplified, so I swing the 2 up. 2x plus 5, I drop the bottom. And then 4 divided by 2 is 2. So this is my simplified numerator. I'm going to come back and type it in. 2x plus 5, x minus 2. 5 divided by 1 is 5. And minus 4 divided by 1 is minus 4. I'm going to come back. That's my factored expression for the bottom. And I'm going to come back and fill that in. I'm ready to do my NPV step, which is my denominator. I'm going to take my denominator, set it equal to 0. You can do it from this step or the factored step, and that's the whole point of factoring it is so you can already know the NPVs very easily. We want to solve for when it equals.
Mom.
We want to solve for when it equals 0. So in order to do that, I take x plus 5 cannot equal 0, and x minus 4 cannot equal 0, and I solve for x in both cases. So I subtract 5 on both sides. X cannot equal negative 5, and x cannot equal positive 4 when I add 4 to both sides. So I can kind of show that step here if people need it. Add 4, add 4. So I'm going to come back and write my NPVs in. X cannot equal minus 5 and positive 4. Oh, and I made a careless mistake. Okay, so my number was negative 2. This number should be negative 2, negative 2, negative 2. And I'm glad I caught it now instead of making the full video and realizing that I made a mistake in it. So this one was minus positive 5 and negative 2. So positive 5, negative 2. 2 divided by 1 is 2. So this one is a 2. X minus 2 cannot equal 0. I'm going to add 2 to both sides. X cannot equal positive 2. And x cannot equal negative 5. And then again, I need to correct this one. Now, the reason I noticed a mistake, and you may notice a mistake on a test, is if I'm asking you to simplify a rational expression and nothing cancels out, then it's kind of a weird problem for me to make you do. So I was like, oh, weird, nothing cancels out. So then I kind of quickly glanced back at my work while I'm talking out loud and realized I had made a mistake. So if you get nothing that cancels, check your work, but there may not be anything wrong. Now I see an x minus 2 in both top and bottom, so I cancel it out and I just write what's left over, 2x plus 5 divided by x plus 5, and x is not allowed to equal 2, and x is not allowed to equal negative 5. And that would be my final answer with my NPVs subbed in. Now, example F is a little bit tricky because what you'll notice is something weird happens. Okay, so I'm going to rewrite this expression 1 minus g, and I'm going to go ahead and factor g squared minus 1. I have two pieces, so what I want to see is there a GCF or is there a common term? Square root of g squared is absolute value of g, but for the factoring purposes, we only write g. Square root of 1 is 1, and there's a negative sign in between, so this will factor as a difference of squares, g minus 1, g plus 1. Okay, once you're done factoring, you would want to state your NPVs. G minus 1, g plus 1 cannot equal 0. So g minus 1 cannot equal 0, and g plus 1 cannot equal 0. In this case, I'm going to add 1. In this example, I'm going to subtract 1. So g cannot equal 1, and g cannot equal negative 1. So those are my non-permissible values. Now, when I look at this, I'm like, oh, this is weird. Nothing cancels. But basically, when you look at it, g minus 1 and 1 minus g are almost the same thing. So what I'm going to try to do is I'm going to factor out a negative 1 out of the top. So 1 divided by negative 1 is negative 1. Minus g divided by negative 1 is plus g. And you're going to notice that those terms are pretty much reversed from the g minus 1 terms in its original form. So this is a positive g, this was a negative g. This is a negative 1, this one is a positive 1. So if you notice that, you should recognize that both terms are going to cancel, and we're just going to try to show it so that they cancel. Now I'm going to swap those two terms around. So this was a positive g and a negative 1. And then you'll notice, maybe you'll notice, that the g minus 1 is an identical factor. It was just kind of hidden as an unidentical factor. So g cannot equal minus 1 or plus 1. So g cannot equal plus or minus 1. Identical factors will cancel, g minus 1, g minus 1. So I'm left with minus 1 over g plus 1. And I state my non-permissible values. G cannot equal plus or minus 1. So this question has a little bit of a funniness to it. It's coming from this term and this term. So if you notice, if two terms look identical, almost, check the signs, okay? Are the signs reversed in all terms? So for example, this one was a plus 1, this one's a minus 1. This is a minus g, this is a plus g. Then the terms are identical and they will cancel, and you'll get a negative 1 for the cancellation. So only works if they're off by a negative sign. Okay? If you're not sure and you think two terms might be following this kind of statement that I'm saying, factor out the negative 1 like I did. That's why I wanted to show it to you factored out, because basically it factored out is the proper way to kind of go through those steps if you're not sure what's happening. Now the last example is a little bit of a more challenging grade 11 example. My numerator is x minus 3y. I know I can't do anything with that because it's a linear term. There's no squares on anything. My bottom sort of looks like a quadratic. I have x squared, x, and number. And then if I look at it the other way, I have y squared, y, number. So it still follows a quadratic pattern. So I'm going to kind of do my same steps. Two numbers multiply to 1 times minus 6, which is minus 6. And the same two numbers are going to add to minus 1, which is my middle term. So we're going to pretend it looks like x squared minus x minus 6. We're going to pretend for a moment. I'm going to go ahead and factor this. So I need two numbers to multiply to negative 6. So negative 6 and positive 1. That won't give me that number. What about minus 3 and positive 2? That multiplies to negative 6. Minus 3 and positive 2. That adds to minus 1. Now when I do my terms in brackets, this is the part that is going to be different. Because normally I would put an x here and an x here, and then the number here and the number here. But now I want to have a y term here and a y term here, because this has a y and this has an x. And then I'm going to put my two numbers kind of in between. Minus 3, positive 2. And I still follow the same thing. My a value is like a 1. So I'm going to divide by a 1, divide by a 1. And I get 3y divided by 1 is 3y with my negative sign. 2y divided by 1 is 2y with my sign. And then that's what my denominator simplifies to. Now this one's a little more challenging because now you have x and y variables involved, but it doesn't change the NPVs. When you're doing your NPVs, you take the bottom. In this case, it's in factored form. You set it equal to 0. Whoops. It cannot equal 0, or you set it equal to 0. So I take each factor, it cannot equal 0. Okay, and I could leave my, whoops, I should write it as x plus 2y cannot equal 0. I'm going to isolate for x, so add 3y, minus 2y, minus 2y. So x is not allowed to equal 3y, and x is not allowed to equal negative 2y. Now, are there any identical terms on top and bottom? Cancel, cancel. So I'm going to write 1 on the top because when I divide, I get an imaginary 1 left over. X is not allowed to equal 3y. X is not allowed to equal negative 2y. And on the denominator, when I simplify, I get just an x plus 2y. And then I'm going to state my non-permissible values at every step. Otherwise, the expressions aren't identical. Okay. So that's kind of the purpose of today's lesson. We're going to simplify rational expressions, simplify things that have polynomials divide by polynomials, and then your main technique to be able to do this is factoring. So if you forgot your factoring technique, so you did really crappy on that outcome, this is where it's going to kick you in the butt, and you still have to review those ideas anyways. So there are questions you can practice in the textbook, but the student teacher and the sub will give you some worksheets that can help you practice the simplifying and the NPVs.